Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, this is lesson 17, graphing the logarithmic function. So now that we've worked with the logarithmic function, now we're going to put it to picture. So here we go. Opening exercise says, graph the points in the table for your assigned function. So in the classroom setting, there would be groups that would be on different teams. One would have a base 10, one would have base 2, and one would have base 5. And we were given 3, 4, 5, 6, 7, 8 points to plot. 9 points to plot. Is it 8 or 9? 9 points to plot. All right, so one group did base 10, one group is doing base 2, and the other group is doing base 5. So I will do base 10 in red. So if I go over 1, up 0, that's right here. What is this doing? Right here. Okay. 2 is a third, 0.3, almost a third, so right about here. 4 is 0.6, a little more than a half, which is right about here. 8 is 0.9, go over to 8, almost all the way up to 1. And 16 is 1.2, which is right here. Okay, so there is that, and then we go negative, and it's going to be over a half, down a third, which is here. Over a quarter, which would be here, down 0.6, which would be a little bit further down here, somewhere around there. And then down an eighth, 1.25, and then it's going to be 0.9, which is over here. And then finally, 0.0625 is 1.2. So there it is right there. So as you can see, this graph is getting closer and closer and closer to the y-axis, but it's never going to get there. And it will increase to infinity as we go right positive on the x-axis. Okay, so here's team 2 in green. Again, it's going to be negative 0.0625 is going to be negative 4. So this point here is going to be all the way down here. And then it's going to be negative 3 at an eighth, which is roughly here. And then at a quarter, it's going to be negative 2. And then at a half, it's going to be negative 1. And then at 1, it's going to be 0, which is right here. And then at 2, it's up at 1, which is here. And over 4 up 2 is here. And over 8 up 3 is here, and over 16 up 4 is right there. So as you can see, it is also curving up and going to positive infinity, going down to negative infinity, but to the left, it will never get to the y-axis, and it crossed at 1, 0. Okay, so now team 5, 0.0625 is going to be negative 1 and 0.72, which is about 3/4 right there. And then 1.25 is going to be negative 1.29, which is roughly here. It's hard to graph these small values. A quarter down 0.86 would be roughly here. And a half, negative 0.43, not quite negative 5 would be here. And 1, 0, over 1 up 0s here, over 2 up 0.43 is right about there, over 4 up 0.86 is up here, and over 5 or 8 up 1.29, which is approximately there. And then finally over 16 up 1.72, which is about 3/4. So there it is. Okay, so there's the 3 values, 3 values, 3 values, 3 values. And as we get closer, and as you can see, all 3 cross right here. So I'll bring in the graph with the lines drawn. I can't draw them with my pen very accurately. Okay, so here is a better representation of what we just graphed, and the points are more accurate here. And notice all of them cross at the point 1, 0. So no matter what our base is, our x-intercept is going to be 1, and there is no y-intercept. Okay, and as the green one, which is what? Log base 2. Let me see if I got these straight. Log base 5 is in red. So actually they did the different color in the teacher edition. So let me switch these around like so. So the red one is team 5. So team 2 is green and then 10. So as our base increases, the function grows slower. 2, 5, 10. Okay, so these are different things you need to look at when graphing. All right, page 2 is just simply asking questions about what we just graphed. So part A says, what does the graph indicate about the domain of your function? So if we go back and look at this graph, the domain are your x values. So the domain gets closer and closer and closer to 0, but then it goes right to infinity forever. So 0 to infinity would be the answer here. So the domain for each of these functions is the positive real numbers, which can be stated as the set open parentheses, because it never gets to 0, 0, comma, infinity, open parentheses. We never use a close parentheses and bracket for infinity. All right, part B, describe the x-axis. Describe the x-intercepts of the graph. So if we go back, for the green one, which is team 2, it's right here at 1, 0. For the red line, or the red function, it's not a line, for the red function, team 5, that was 1, 0. And for the blue function, which is team 10, that was also the point 1, 0. So to answer that, we would say there is one x-axis or x-intercept at 1, and we can also add that it is the point over 1. Up 0. All right, part C. Describe the y-intercept. This keeps jumping on me. Describe the y-intercepts of the graph. So if I go back and look, the y-intercepts, well, they're never going to get to the y-axis because I cannot take the log of 0. It'll give me an error. So I cannot plug 0 in for x. It'll never get, and we can't take logs of negatives. So the y-intercept, there are no y-intercepts of this graph. Okay. Moving along to D. What's that jump? Find the coordinates of the point on the graph with y value of 1. Okay, so we're going to get different answers here. So we're going to come over to the graph. A y value of 1 is right here. Right here. And it hits 1 right here. So for team 2, it would be the 0.21. For team 5, it'd be the 0.51. And for team 10, it'd be the 0.101. So in other words, whatever your base is, it's going to have a y value of 1 at that value. So if you take log base 10 of 10, it's 1. Log base 5 of 5 is 1. And log base 2 of 2 is 1. And if you look at the graph, here's 10. They don't show 10 here, but it's between 0.9 and 1.2. This is team 2, and it is actually 2, 1. And team 5, they skipped 5. It'd be between 4 and 8, which would be right here. So it's in between 0.86 and 1.29, and it is actually 1 as well. Okay, so to answer this question now, we would just simply say, for team 10, this is 10, 1. For team 2, it was 2, 1. And for team 5, it was the 0.51. All right, part E. Describe the behavior of the function as x goes to 0, as x approaches 0. So if I go back to my graph, as x is getting closer and closer to 0 this way, we're getting closer and closer to negative infinity. All right, so we want to save that for all 3 functions, actually. So if I go down here, it says as x approaches 0, the function values approach negative infinity. That is, f of x approaches negative infinity. The same is true for the functions g and h. In other words, all three functions are going to negative infinity. All right, f. Describe the end behavior of each function as x approaches infinity. So now we're going to look at the end behavior. As x gets bigger and bigger and bigger, these functions are going to keep going up and up and up. One is faster than the other, and this one faster than the other two. So in other words, the smaller your base, the faster it grows, but they are all going to go to positive infinity. So we want to say that. As x approaches infinity, the function values slowly increase, but f of x is going to infinity. The same is true for both of the other two functions. All right, G says to describe the range of your function. Remember, range is your y values. So it's going to negative infinity this way. It's going up to positive infinity this way. So the range is the set of all real numbers for all three functions. Okay, so that's what I'm going to say here. The range of each of these functions is all real numbers. In other words, negative infinity to positive infinity with open brackets. Part H, does the function have any relative maxima or minima? And explain how you know. Well, the relative max means it's going to go up to a certain point, stop, and then come down. Or minima, it's going to go down to a certain point, turn and come back up, and it doesn't go any lower. Well, if we're going to negative infinity and positive infinity, that can't happen. So since the function value continue to increase and there are no peaks or valleys in the graph, the function has no relative maxima or minimum. It's a continuous growth function. As x increases, y is increasing, always. Okay, and that was the last question on that page. All right, page 3 is now going to give us bases that are between 0 and 1. So we've already done 3 functions where we took base 10, base 5, and base 2. So those are all values greater than 1. Remember, we can't take the log of 1 because then it's not a logarithmic function. It's just a constant function because base 1 to any power is just 1 and it's a constant function, not a logarithmic function. But then what happens when we take logs between 0 and 1? So remember, we cannot take logs of 0 or negatives or 1. So again, if I go in my calculator and take the log of a negative number, it gives me an error. If I take the log of 0, it gives me an error. And if I take the log of 1, the log of 1 is 0. And that is just going to be a constant function. So we don't want to take the log of 1 either. It's always 0. All right, so if we took the log of a negative now for base, actually that would be log base 1. So let me just see, log of 10 divided by log of 1. Remember, log of the big divided by log of the little being the base, and we're going to get an error divided by 0. So that's why we can't take the log of 1, because the log of 1 is 0 and it can't be in the denominator from our change of base formula. Okay, so exercise here is going to take a look at bases that are between 0 and 1. 1/10, 1/2, 1/5. So just to save time here, I'm not going to go through and plot them all. We all know how to plot points on a graph. So what we're going to get when we do this, and we're graphing between 0 and 16, and here are the values that were given. So there was a team 1/10, a team 1/2, and a team 1/5, and they call them team 10, team 2, and team E. Okay, so anyhow, here is what these 3 functions look like when they were graphed. So notice it looks like it's just flipped over the x-axis from the log of numbers that are greater than 1 with base of greater than 1. So it's coming down from infinity, all crossing at 1, 0, and then decreasing. And the values that are closer to 1 increase or decrease faster, and the logs that are closer to 0 decrease slower. So there are the 3 graphs. And now if we answer these questions, what is the relationship between your graph and the opening exercise and your graph from this exercise? Okay, so what you would say is the second graph, this one, is a reflection of the graph in the opening exercise across the x-axis. So if I go back to the opening exercise, there's the graph reflect all of these functions over the x-axis, and that's how we get the numbers that are base fractions. Okay, and then it says, why does this happen? Use the change of base formula to justify what you have just observed in part A. So what you're going to do is, using the change of base formula, we have the log of base 1/2 of x equals the log base 2 of x divided by the log base 2 of 1/2. Okay, so once I do that, then since log base 2 of 1/2 is -1, we have the log of 1/2 of x equals log base 2 of x divided by -1. So the log of 1/2 of x equals the negative log base 2 of x. Thus, the graph of y equals log base 1/2 of x is the reflection of the graph of y equals log of 2 of x across the x-axis. Okay, so that's the explanation using change of base formula. Okay, page 4, number 2, it says, in general, what is the relationship between the graph of the function y equals f of x and the graph of y equals f of some constant times x, k of x, or kx, f of k times x for a constant k. And the graph of y equals f of k times x is a horizontal scaling of the graph of y equals f of x. Okay, and now they're asking us to graph the points in the table for your assigned function u, v, and function w, where it's base 10, base 2, base 5, but then we're taking a multiple of the base in each one. Okay, so this one here, we're going to just graph. So team 10 first, and 0.0625 is way over here, close to 0. And I got -0.2. So here's 0.5, 2.5, I would say right about here. And then 1.125, 1/8, comma, 0.10. So that'd be like right here. And then a quarter, comma, 0.4. Oops, I didn't put that other one in the right place. It's positive. This has to be moved up to 0.10. 1/8, 0.10. This is closer to the y-axis. So these ones that are close to the axis are really tough to graph. All right, so now a quarter, go over a quarter, which is here, and up 0.4, which is about there. Okay, and then 0.5, 0.7 is here, and 1 is here. 2, 1.3. 4, 1.6, 8, 1.9, 16, 2.2. Okay, so there is team 10. I will do team 2 in green. 0.0625 is -3, that's way down here. 0.125 is -2, that's an eighth. 0.25 over a quarter, -1 over a half, 0, which is right here. 1, which is here. 2, which is here. 4, 3, right here. 8, 4, right here. And 16, 5 is up here. All right, now finally team 5 in blue, 0.0625 is -0.72, which is about here. 1/8 -0.29 is about here. A quarter, positive 1.14 over a quarter, up a smidge, right there maybe. 0.5, 0.5 up 0.57, a little more than a half right there. 1 again right there. Over 2 up 1.43 is about here. 4, 1.86 is about there. 8, 2.29 maybe there. And 16, 2 and almost 3/4. Okay, so there are the three graphs. I'm not going to connect them with the lines because it's hard to do with my pen, but you can see where they would be. All right, so now we have to answer the questions that follow. Okay, page 5, part A says, describe a transformation that takes the graph of your team's function in the exercise to the graph of your team's function in the opening exercise. So what I would want to do is here, let me just do this. I'll go back to page 1 and I will copy this and bring it over and we'll compare. Okay, so there it is, and copy, and let's go back to here and paste, and let's bring this function down so that we can see both of them. Okay, right about there will work. So here we go. So we're comparing these two graphs. So if I look at the green one, that's log base 2 of x. That would be the green one up here. And it only got to 4 where this one got to 5. This one got to 3. This one got to 4. This one got to 2. This one is y equals 3. And at this point, we're at y equals 1. And this one, we're at y equals 2. And this is over 1 up 0. And this is over 1 up 1. So it looks like these were all shifted up 1. Now keep in mind the blue one and the red one, I used the wrong colors. All the blues should be red and all the red should be blue. So that's not a good comparison. So let me fix that. Okay, so I fixed that now. So now the red is between the blue and the green, just like down here. So as you can see, looking at the green one was the easiest one to use. It was a shift up 1. But if I look at the blue one, log of x, log base 10 of x, 16 was 1 point, let's see, what was it? Let me go back. What was 16 for our log 10? Page 1. 1.20. Okay, and this 16 is still, or it was 1.20, now it's 2.20. There we go. 8, 0.9 is now 8, 1.9. So these were all shifted up 1. That's all it was a shift up 1. When we take and multiply it by a constant that equals our base, it shifts the whole function up 1. All right, so now let's answer the questions. Describe the transformation that takes the graph of your team's function in the exercise to the graph of your team's function in the opening. And you would say the graph produced in the exercise is a vertical translation of the graph in the opening exercise by 1 unit up. And then part B says, do your answers to exercise 2 parts A and part A agree. Exercise 2 and part A agree. Okay, and then if not, use properties of logarithms to justify your observation. So the answers to exercise 2 and part A do not appear to agree. Okay, this said it was shifted up 1, and the answer to exercise 2, let's go back to that. The second graph is a reflection, and the other one was a shift up. Okay, so it says, however, because log base b of bx equals log base b of b plus log base b of x, which equals 1 plus log base b of x, the graph of y equals the log base b of bx, and the graph of y equals 1 plus log base b of x coincide. Okay, so using our rule, our product rule, justifies the fact that it was shifted up 1. All right, page 6 brings us to the end of lesson 17. Review the lesson summary and go do your problem set.